Hello everyone, my name is Mateusz Buczkowski and I would like to introduce myself because we didn't have an opportunity to meet in person due to my sick leave at the beginning of the semester. So in this short video I would like to say a few words about how should you approach the different tasks, and I'll show you how to solve in particular one of them, because I think it might cause you some problems. So first of all, I would like you to focus not on math and fighting with fractions or something like that. You can easily take some roundings and don't focus on precise calculations, rather on how to solve the problem. And I would like to show you the solution or some guidance to the first task in the second exercise. This is a triangle, and actually 3 triangles. We have 10 resistors, and what we are going to do is to simplify this graph into using y delta transformation. Okay, so for first thing we can do is we can simplify this triangle into y connection. So we'll end up with something like this. Okay, we can also simplify the second triangle right here. So we have resistor here, right here, and right there. Okay, and what is important to notice that this isn't a triangle as 2 previous, because it doesn't have a node right here. These 2 resistors, R9 and R10, are connected in series, so we can simplify them by calculating equivalent resistance just by adding these 2 resistance. Okay, so we have this resistor R8, which is exactly the same value, and second resistor, which is equivalent to these two connected in series. Okay, so this is R9 plus R10. Values for each of these resistors you can of course calculate from the formulas that are given in the materials. So this resistor is calculated from this triangle, and so on. These resistors are calculated from this triangle. And if we have graph as this scheme as follows, we can connect and calculate equivalent resistance of these 2, because they are connected in parallel. So we can easily calculate equivalent resistance of these 2. So again, we end up with something like this. And then again, we have 2 resistors in series. We can simplify them, as well as these 2. Okay, so we have 2 resistors in series and 2 resistors in series. Oh, maybe actually even 3 right here. Okay, so we can easily simplify this. So we have single resistor between these two nodes, this one and this one. Okay, so we have single resistor right here, which is equivalent to this, and single resistor here, which is equivalent to this. Having this, we have resistors in series right here, in parallel in here, which can be simplified to something like this: single resistor, single one, and last. Okay, so we end up with a really easy scheme with 3 resistors in series, and we can easily calculate equivalent resistance by adding these resistances. Okay, so this is how we can calculate total resistance. We have given current, so we can easily calculate what is the voltage drop on this equivalent resistance. Okay, so this would be the solution to the first question, or both questions. Okay, so what is the total resistance and the total voltage across resistance? Okay, so now when we want to calculate voltage drop on a single resistor, which is this one, we can use delta Y transformation in different places. So we can use it right here. So let's try to redraw this scheme. So these two resistors are exactly as they were. Here we have first resistor, second one, and last one from this transformation, and the rest stays as it was for now. Oh, sorry. Of course, this one isn't there because it's already removed by the transformation. I made a mistake, and these two, okay, as they were. This is the source of the current. Now what we can do is of course simplify these two resistors because they are connected in series. So we have now single resistor right here. Okay, and now what we have is a new triangle right here. Okay, we have 3 nodes, and let's simplify this by creating Y connection between these 3 nodes. What is important is that this resistor must be left unchanged, okay, because we need to calculate the exact drop on this resistor. So during this transformation, this delta Y will change only these three resistors. So we have this node, and this one. So we will have a resistor right here, right there, and one right here. Okay, and what you can see is we have these two in series, these two in series. So let's simplify that again. Okay, and again we have we can use the delta Y transformation in here. So between these three nodes we'll have resistor right here, resistor right here, and resistor right here. Okay, so we're fairly close to the solution. What we can see here is we have these two in series. We have three in series, but we cannot move this one because this is our the target where we want to calculate the voltage, but we can connect these two. Okay, so sorry, I'll just make it a little bit higher. We reached the very simple scheme. We already know what's the current. We can calculate the resistance in this branch and in this branch. So we can easily calculate how does the current, in what proportions does it flow into each of the branches, and knowing that and knowing this resistance RA, we can calculate the voltage drop. So I hope that this short guidance showed you that how to deal with such problems. If you have any questions, feel free to ask me. And just to clarify, I would like to say that I'll record one more video in this week to show you how to solve the tasks I have given you. And in the next week, I will try to schedule an online meeting so we could solve some problems online. I will introduce you to some new problems, and perhaps you'll have an opportunity to ask me some questions. Yeah, and I hope soon enough I will be able to work in class. It will be much easier for both of us. So See you soon.